Okay, so just to start, we're going to ignore this little precursor because I want to talk about this. What is, if I have 12 and 9, what's the greatest common factor between them? What's the biggest number that when I multiply it by something, I can get 12 or 9? 3. Okay. What's the biggest common, what is the greatest common factor between 24 and 42? 6. Okay. All right. So that's what we're talking about when we're talking about the greatest common factor, except in this case, we're going to have some variables. We're going to have things like x and stuff to go with it. So we're going to move down, all the way down to example 1. The greatest common factor between 12 and 9 is 3. Between 24 and 42 is 6. Okay? You've probably done greatest common factors like this before in middle school or elementary.
The Christmas tree.
Now we're going to do greatest common factor where we have letters as well. All right. So we've got 12x to the 5th plus 8x to the 4th minus 6x to the 3rd. What do all of the coefficients have in common? What number goes in all of them evenly? 2. So we're going to take out a 2. How many x's do we have?
3.
That's the smallest one we have, right? So we could take out 3. So we can take out x to the 3rd. So we can take out 2x to the 3rd. Now, I want to know what's left over if we divided all of those by 2x to the 3rd. 12 times what? 2 times what gives me 12? 6. How many x's would I have to do?
5.
To get 5, 3 and what gives me 5?
2.
2, good. Plus, 2 times what gives me 8?
4.
How many x's?
1.
There you go. And then 2 times what gives me negative 6?
Negative 3.
Good. How many x's do I need?
0.
There you go.
Can you like? So
I'm
you just take it and
Yeah.
times it by everything, right?
So, the first thing I do, step number 1. Okay, if I was going to write down my steps, step number 1 would be, I don't have my mic on, sorry guys. I just kind of feel like I'm shouting. All right. Step number 1 would be to ask yourself, what is the greatest number that can go into each number evenly? Okay? And then step number 2 would be take out the most variables you can. Step 3 is kind of reverse distribution property. So I know this is my answer when I get a distribution, so I'm just kind of reversing it. 2x to the 3rd times what gives me 12x to the 5th? Okay, 6x squared. Yes.
So you're just saying,
Hold on, Alexis.
where do you get x to the 3rd from?
Well, I know that the biggest one I can take out is x to the 3rd. It is the smallest one, but I have to take out the biggest, smallest one, if that makes sense. Because I could take out one x, right? I could take out an x just from each of them, right? But then I would have x squared left over. And I would have x to the 3rd, and I would have x to the 4th. Well, I can take more than that. So you look for...
So if there was like 4 numbers and each of them had x, that would be x to the 4th?
Yeah. You take out whatever the smallest exponent is.
But you said take out the most.
x's that you can. So the smallest x I could take out is x, right? But I want to take out the most x's I possibly can.
So let's take out the number of x's there actually
No.
is.
Grace, I want to take out the largest amount of x's I can. 'Cause I could just take out an x, correct? But I would have x's left over for each term. So I want to take out the most x's I can so that each term has the least amount left over. Yes.
So you just take 3x to the smallest
Yes.
and subtract it from each. Okay, and then
You're not
2x.
subtracting, but yeah, you're dividing.
You, so you find what goes evenly
Yes.
into each of them,
Yes.
and then you just. Yeah. Okay.
Let's try another one. Okay, let's think about the greatest common factor for these two terms, just this little binomial. 3 is the number, right? So my first step, take out the biggest number. Okay, and that, in this case, we know it's going to be 3. Is there any x's I can take out?
Yeah.
When you say biggest number, is that just the greatest common factor?
Yeah, greatest common factor. Okay, is there an x for both terms?
No.
No, so there's no x's.
What?
See how there's none for this one? So I can't take anything out of it. So I'm going to have, now I'm going to write what I have left over. Okay? If I took out a 3, if I divided all of these by 3, I would have 5x squared plus 6 left, right? So my answer looks like this. 3. 3 times what gives me 15?
5.
I have to have an x squared to get this term, correct? Okay. Plus 3 times what gives me 18?
6.
Good. That's it.
So I'm just confused on the exponents for putting it in for like the last problem. I didn't.
We're going to do more with an exponent. I just
Okay.
want to make sure you kind of get this whole idea. Now we're going to do more.
What if it's not squared?
If it was just an x,
Yeah.
still can't do anything because 18 doesn't have an x.
So would it be 3
Times 5x plus 6 would be 19. Right, you ready for some more?
No.
No.
Okay, I'm going to do A for number 2, and then I want you guys to try and do B. Okay? So the first thing I look at is, okay, this has a 1, this has a 5, and this has a negative 22. There's nothing besides 1 that I could pull out then, right?
Yeah.
Okay. So I can't pull out a number, right? Because 1 divided by 1 gives me 1, 5 divided by 1 gives me 5, 22 divided by 1 gives me 1. But I can't do anything bigger than that because the biggest number this one has is a 1. Okay. How many x's do we have here?
3.
How many go here? 2, right? X squared. So there's 2 x's. How many x's are here?
1.
Okay. So what is the smallest exponent there? X to the 1. So I can only take out an x. What do I have left? X times what gives me x to the third? Yeah.
Okay.
So x times what gives me x to the third?
X to the second.
Good. What x times what gives me 5x squared? 5x. Good. What times x gives me negative 22x? There, I'm done.
Good. Could you go back to the beginning where it's like you're counting up all the x's?
Yeah. So I'm looking through here, and I know if I was going to write this out, I would have 3 x's plus 5 times 2 x's minus 22 times an x, right? If I want to divide or pull out an x from all of these, guys, you got to be quiet. Remember, this is recorded. Hold on. if I want to pull out an x from each of these, right? Because I know there's at least one x for each. So I pull out an x, I pull out an x, I pull out an x, I put the x on the outside. I'm left with x squared
So you wanna go to the smallest amount of x's.
plus
and then take
5x
that out of all.
minus 22. Yep.
Oh, I see.
So do you see that they all have an x? In each term has an x with it. Okay? So I can pull out an x. Why can't I pull out two x's? This one doesn't have two x's, does it? So I can't pull out something that I don't have. All right. All right. Why don't you guys try B? What's the biggest number? Take that out first. Then you can take out so many y's. Try it right now.
Is that the other way to do it? Okay.
Try it right now. Give everybody a second to try it. Yeah, x with y. Because they're all y's, right? That looks good to me. Giving you one more second. Try it out.
How do you take the negatives into consideration?
Just keep them in the problem if you can. Okay, you ready? All right. You can take out a 2 out of all of them, right? Is there anything bigger? 4.
4.
Okay, so some of you put 2, and it's 4. So we're going to take out a 4. Do we want to take out, you can put 2, but then you could just have to take another 2 out later. Okay. Do we want to take out a negative 4 or a positive 4? Let's try positive 4 first, then I'll show you how you can do it for negative. So we can take out a positive 4. What's the smallest number of exponents there is? So we have to take out y to the 3. 4y to the 3 times what gives me 16, negative 16y to the 6? Negative 4y to the 3rd. What? 4 times what gives me 28? Y to the 3rd times what gives me y to the 4th? Y. 4 times what gives me negative 20?
5.
And y to the 3rd, get y to the 3rd, we just get that. We good? Okay. Do you want to see what it looks like if I pull out a negative 4y to the 3rd or no? Okay. I'm just going to say it out loud then. What would happen if you pulled out a negative 4y to the 3rd is all of these would change signs. This would be positive, this would be negative, this would be positive. That's it.
Oh, but would it change it? Like, would it, okay.
That's the only thing would change. Your signs would change.
Would you change the first sign too, like on the outside?
Yes. So it'd be negative 4y to the 3rd times 4y to the 3rd minus 7y plus 5. Okay. All right. You ready for a word problem?
No.
I hate work.
All right. You want? Should we have more practice first before we go to word problems?
Yes.
Want some more practice? Okay.
What about the ands? On home, this is 10x and 25.
Are you gonna get
Let's
it?
try this. So you can like add more problems down here if you want, or on the side of your paper or wherever. I'm gonna put it on a separate sheet of paper just so it's neater for you guys to see. Okay? So let's do this. That's a 2. Okay. What's the biggest number that goes into all three of those? 5. Right, can you guys see that right away? The 25, 15, and 20, the biggest number that will go into them all is 5. Okay, so I'm going to put my 5 on the outside.
Oh,
Okay, now let's look at just the x's. What's the smallest exponent for x's that I can take out?
X second.
What's the smallest y I can take out? Look again.
Y.
first.
Y. Okay. 5 times what gives me 25?
9.
Do I need an x there? Y times what gives me y to the third? Good. 5 times what gives me negative 15? X squared times what gives me x to the third? Do I need a y? Okay. Plus, because there's a plus, right? 5 times what gives me 20? X squared times what gives me x to the fourth? Y times what gives me y squared? Good?
You could just subtract it, right? If you wanted to.
Subtract what?
Like x squared, like x to the fourth minus x squared on the bottom equals 4x squared.
What?
You can't subtract the numbers, but you can subtract the exponents.
Yeah, the exponents, not the numbers, the exponents.
The exponents you can totally do. You want another one?
Okay, I think I know.
Can you do number 10 out of
No, but I could do one like it.
Yeah.
I don't want to do one of your homework.
We only have like 12 problems.
Right, nobody jump. What?
Don't complain about just 12 problems.
So, okay. All right. We've got 2. Hey, for something like number 10. Yeah. What's the greatest common factor of? We'll do.
For 6 through 16, are we doing like the same thing that we just did?
Yeah.
Because it's like and not like a bit.
Yeah, that's why I'm doing one like it.
Oh, no, not the line. Was that 21 or the line?
21.
Oh.
Yes.
Is that it?
So 7. What else?
Oh, yeah.
A to the what?
4.
Okay.
What?
This is a to the 6th, and this is a to the 4th, so I can only take away 4 a's, right? Because I can't take away 6, because then this would have -2, and we don't want negatives.
Ah, right. And then take away.
So,
That's why.
what would I have to times this by to get that?
2.
2 what?
2a to the second.
What would I have to times this by to get this?
3b to the third.
Okay, I don't need this part. This is just what it's asking you for 6 through 16. Just to do that. Okay. Do we want another one? Or we want to try a word problem?
Wait, 6 through.
Let's try word problem. Yeah.
6 through 16 even. Yeah. Let's try a word problem then. And then you guys should have time to work on your homework even after I go over the quiz. Okay. So, our word problem is is in charge of marketing for a travel company. She's designing a brochure that will have 6 photos. The photos can be arranged on the page in a number of ways. There are 2 main square photos, which have a side length of x. There are 4 narrow photos that are each 1 inch by x. 1 by x. What are the total area of the photos? Okay, so how many of them are x times x?
2.
So we have 2x squared. Everybody okay with that?
Yeah.
Yep.
That's those. What about the other ones? How many are there?
4.
4.
1.
And what are they times? 1 by,
X.
so just times x, right? So far so good?
Yes. And if it was like, if you're trying to divide by 2x, it would be x squared. And
Yeah. Okay. So that's the first thing it's asking us. Let's go to B. B.
Do we have word problems or homework?
Yeah, but they're easier than easy.
Okay.
Okay, we're going to place this in a rectangle. So I want to move these so it's just one straight long rectangle. Okay? So I want to move this up here and then the 2 little narrow ones like that. What would it be? Okay, instead of just finding the total area, what are the measurements? So, we have okay, I know this is x, right? And that's the width for all of them, right? This is x, this is 1, 1, 1, 1, and this is x. Everybody okay so far? Okay. So we're going to say x times, how many x's are there? 2, so we say 2x. How many of the ones are there? We can count them up and we get. See how that works? That's the answer. Yeah. Okay. So, Elena is in charge of marketing for a travel company. The photos on the page. Factor out the greatest common factor of the polynomial. What does the greatest common factor represent? So if we go back to A and we have 2x squared plus 4x, what's the biggest number that can be factored out of that?
2.
What's the most amount of x's?
X.
So what do we have left over? 2x times what gives me x squared? 2x squared.
2x times
X.
x.
What
Plus 2.
plus 2? We just took out a 2 out of everything. We just took out of x out of everything.
X, yes, okay. Now
Okay.
you're subtracting numbers?
I didn't subtract. I'm dividing. Always dividing. Just it happens that 4 divided by 2 is the same as 4 minus 2, okay? Alright. So that's it for that.
Make it sound so easy, but I don't know, it's not,
I know it's hard for me not to make it sound easy. You know, when I did this, I was your age, right? So I've been doing, and I became a math teacher, right? So it's not like I ever stopped doing math.
Don't you change it?
It's just, algebra has been the same since they invented algebra. So they might change the word problems or some of the vocab they learn, but none of it. So I'm not trying to insult anybody by making it sound easy. I've just been doing it for a long time. It's not easy though, the first time we do it. Okay, let's do D and then we'll be done. Okay. D says, Elena's in charge, blah, 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 blah. Which of these 2 arrangements is a more practical use of space on a page of brochure? Would I more likely use this one? X times 2x plus 4. Or would I more likely use this one? 2x times x plus 2.
2x.
I think I would use this one more in our brochure. Have you guys ever seen a brochure that's long like that?
No. Never.
Yeah.
Mine is always open like that.
Yeah.
And when you open the brochure like this, you probably don't want to have to turn it sideways to see the pictures, right? You just want to open it to see it. So, your homework is very close to these. Okay? Everybody should be fine doing them. You have your homework, and I'm going to put it on the video just to make sure. I put it all kinds of places. On the board, on PowerSchool, now I'm putting it here. 284, numbers 6 through 16 even. And 26 through 34 even. Okay? And if we have questions, what should we do? If you get stuck on something, what should you do? No, you should email me. Because I can't stay after school, but I can email all the time. I can email and play with my kids.